Our first question is on the screen. It says we are looking at the sine of x. Let me copy the question here. The sine of x plus the cosine of x, all of that squared, minus 1 over 1 minus the sine squared of x. And for 4 marks, folks, we are instructed to simplify this expression. Now remember, I say this over and over again when I teach trigonometry. You do more algebra when you do trig than what you actually do trigonometry. And this is a perfect example of that. Our very first step is not going to be a trigonometry step, it's going to be an algebra step. Let's see what I mean. If I look at what this is instructing me to do, let me bring that down here. There we go, then we have more space. Okay, that's telling me take sine plus cos, square it and subtract 1. Now if I carry on from there, this will become sine squared x plus 2 sine x cos x plus cos squared x minus 1. Now remember, that is based on your rule. If you have a binomial and you square it, it becomes a trinomial. Okay, there's that middle term 2ab. And this is what happened over here. There's a squared, b squared, there's 2ab. Now the denominator I can't do much with, so I'm going to leave it for now as 1 minus sine squared x. Now let's see what combinations we can work with at the top. There we have sine squared plus cos squared. Now folks, we all know since grade 10 that that is 1. So that 1 minus this 1 takes care of those 3 terms. So what am I left with? I'm left with 2 sine x cos x. And if I peep at the bottom here, this is going to become, in my next step, is going to become cosine squared x. So I had 2 choices here. I could have left it as it is, or I could have applied the identity that says the sine of 2x is 2 sine x cos x. So folks, don't just think when you see something that looks like a double angle or a compound angle that you have to apply your rules. In this case, it was not necessary. We left it as 2 sine x cos x, and look at what happens now. I have 2 sine x cos x at the top, and that simplifies beautifully to the square, and the cos goes away. I have 2 sine x over cos x, and we all recognize that as our quotient identity for tan x. So that fraction simplified beautifully to 2 tan x. Now that was, by the way, was for 4 marks. So you'll get your marks for applying the identities, and you'll get your marks for the simplification. Not a nice or difficult question to start the trig section with. The next one is interesting. Look at this. They say to us, the cosine of 2 theta in terms of p is what we want. And what do they give us? They give us the sine of theta is 1 over p for 3 marks. Okay, so we're going to start and we're going to work with what they gave us, folks. We always start with that. I'm going to call that part B. They tell us the sine of theta is 1 over p, and they are looking for the cosine of 2 theta in terms of p. Now, again, you have options. Okay, there's a theta and there's a 2 theta. Now we are lucky with this option. With this option, we're going to do minimum amount of work. Remember your identities, folks. Don't forget them. Cos 2 theta is cos squared theta minus sine squared theta. It can only be, also be rather, 2 cos squared theta minus 1, or 1 minus 2 sine squared theta. And I'm a lazy mathematician. I'm going to use the third one because I have the sine of theta. And this is, let me just make 100% sure, yes, this was for 3 marks, quite nice. Okay, so we chose the third one that has the sine in it. And we're going to start and say, okay, we know, because we know our work, that the cosine of 2 theta is 1 minus 2 sine squared theta, which is 1 minus 2, 1 over p, it is squared, so 1 minus 2 over p squared. So again, your marks will most probably be 1 for the identity, 1 for the substitution. However, I think that mark is wasted because you're just plugging it in. If you didn't recognize this, you wouldn't know what to do here. And then 1 for your final answer of 2, 1 minus 2 over p squared. Let's just see. Yes, we answered the question. The next one is quite nice for 6 marks. I'm going to write the question down here because it's very unclear at the top. So let me write the third question here. It says, without a calculator, find the general solution. Okay, so where are we now? We are at equation solving. Now remember, matrix, to solve equations, you're either going to need your rules or your definitions for basic trig equations. Those are the sine of theta equals a number. Then you just inverse sine the number to get to the angle. Okay, or we're going to apply identities. Now I'm not going to string all the identities down in here. And the third one that we always forget about is the co-ratio problem. So I'm going to put it here. I'm possibly going to end up with a co-ratio. So let's see. That's the 3 key ideas behind solving equations on your paper. The equation they give us is the sine of 2x, the cosine of minus x, plus the sine of minus x, the cosine of 2x minus 360. And they tell us that is equal to the sine of 390 degrees. 6 marks for a general solution. Okay, now let's see. What is hidden here in my, that was my phone. Sorry, folks. What is hidden here is my identity. I will highlight it for you over here. My identity is saying the following. It is telling me that I must take the 2x minus 360. Work with that first. Why is that the case? Well, I know that the sine of A, the cos of B, plus the cos of A, the sine of B, means I can combine the two together. Okay, I can combine them. Now let's have a look. What does this mean? Now, folks, you're not going to play around with a calculator and do funny stuff to this in an exam. You're going to interpret it for what it is. That little identity there is 2x. 2x lies in the first quadrant. And what must I do? I must subtract a revolution. So it's a nice way of trying to confuse you. This is nothing other than the cos of 2x. Okay, so let's start here. The sine of 2x, this is a 4th quadrant angle where cosine is positive, leaves us with a cos of x. Here I'm going to deliberately change these two around. It's a product. So 2 times 3 and 3 times 2 gives me the same thing. So I've got plus the cosine of 2x, and then here there's something funny that's going to happen. It's a 4th quadrant angle. Sine is negative, so minus the sine of x, which means it's going to change this positive. Now on the right-hand side, folks, we have 360 plus 30, and that is just the sine of 30 degrees. Okay, now let's see what happens here. I'm going to change that so I don't waste time. I'm going to make this a positive and change this into a negative. Now look at the poetry that just happened. My identity says that the sine of A, the cos of B, minus the cos of A, the sine of b is the sine of a minus b. Okay, so let's apply that. This becomes the sine of 2x minus x, and that just leaves me with an x. On the left-hand side, that whole thing reduced. Now, please, folks, there was a 2x there and there was a 2x there. Remember what I said 5 minutes ago. Don't think because there's a double angle or a compound angle that you always have to expand it. This is a perfect example where you would have gone into the labyrinth if you changed the 2x. Okay? You didn't want to change it, you keep it. Okay, now look at how easy this is. This is equal to the sine of 30. Now the sine of 30 we all know is a half. Okay, we could leave it over there, or we could go for our definition now. So now for the general solution. Therefore, what is x? X is equal to 30 degrees, or in the second quadrant, 180 degrees minus that 30. Okay, so I'm leaving it at that stage. Plus multiples of the period for sine, where n is an integer, and that finally just gives me x is 30, or 150, plus multiples of 360, where n is an integer. Okay, folks, so you would have gone totally off the rails there if you took that 2x and you expanded it. You have to practice your trigonometry. If you're scared of trigonometry, folks, the more you do it, the more you're going to see when you need to do things and when you don't. Let's look at the next question on this paper. It's an identity. It asks us to prove the following. Okay, this is part D. It says 4 times the cosine of theta minus 1 plus the cosine of 2 theta over the cos of theta is equal to the sine of 2 theta over the sine of theta. Now we are asked to prove that this is the case, that this is indeed true. Now again, if we analyze this, on the left-hand side we have a fraction, which we can add with an LCD. So we're going to do some algebra first. On the right-hand side, we have a double angle, and we're going to divide by sine theta, so the right-hand side can possibly go down to 2 cos theta, and that's the most we can do. Okay, so I am going to start with the left-hand side. Let's see. There's more things to do, and there's more information for me to use. If I now go with the left-hand side, my LCD is cos. Okay, so I'm going to immediately put it on the same denominator. 4 cos squared theta minus, now be careful, this is a serious catch. There's a negative in front of the fraction. So in your head, there must be an invisible bracket around that numerator, because that negative must distribute to both the terms. Look at this. If I put an invisible bracket here, that negative is minus 1, minus times a positive is minus cos 2 theta. That there was the big trap in this question. Okay, now we've got to choose. Remember, for the cosine of 2 theta, we have 3 identities that we can pick from. And I think the one I'm going to pick, and I'm sure you'll agree with me, is the cosine one, because we saw that the right-hand side is going to reduce to twice the cosine of x, of theta rather. So let's do that. 4 cosine squared theta minus 1 minus, now make use of brackets. You don't want to make silly mistakes here. This is twice cosine squared theta minus 1 over the cosine of theta. Okay, a little bit of algebra now distributes the negative. Let's go step for step here. so we don't make a sign error, minus 2 cosine squared theta. And if you didn't put this in a bracket, folks, you would slip over that double negative, which becomes a plus 1, over the cosine of theta. Okay, so 4 cosine squareds minus 2 cosine squareds is 2 cosine squareds of theta. Minus 1 plus 1 taken care of. Still 0, nothing has changed. Cos theta in the denominator, that gets rid of the power at the top. I have 2 cos theta. Okay, now let's see. Our right-hand side asked us to get to sine 2 theta divided by the sine of theta. Okay, now I can be clever here because there's no sine theta left in the denominator. So what I can do here is I can multiply both the top with a sine theta and the denominator, with a sine theta. Now if I do that, I bring in the right-hand side. I have 2 sine theta cos theta, which is the sine of 2 theta, all of that divided by sine theta, and that is indeed my right-hand side. So I just need to conclude that the left-hand side is identical to the right-hand side in this particular question. Now, folks, remember, just a good reminder, friendly reminder, when you solve an identity, you do the left-hand side by itself or the right-hand side by itself. You don't do them side by side. Start with the one side, simplify as far as possible. It's an identity that you're proving. You can't treat it as if the left-hand side is equal to the right-hand side from the onset. You need to show it. Okay, so keep those sides apart.